Hi guys, today we are going to discuss about the modeling and simulation in product. Modeling and simulation significantly shorten the design cycle and reduces the cost of the design by creating and analyzing virtual models which otherwise would have been complex with physical prototype. By modeling and simulation process, we can able to optimize your design as well as we can able to reduce the cost and time. Suppose if people are in a flight academy, they want to train pilots. So for the pilot, they would give directly the flight to them. Instead of flight, they will give the flight simulator. So by that way, they can able to train it. After the training, they will go for the real-time environment. And similarly, the same things they are following in the ship industry also. So by this way, we can able to optimize the cost. And suppose if a ship they are testing in sea, it will take more money, and if you are making the prototypes also, it will make more money. So instead of doing that one, we can able to make a virtual environment, and then we can test our design, and then we can able to optimize our design by your virtual simulator. So by this way, we can able to reduce the cost of your prototype. So that is the main advantage. Reduction in cost and design cycle are crucial to remain competitive in a world where pace at which new consumer products are being developed is ever increasing day by day. Your modeling and simulations allows evaluating a model to optimize your product or your system performance, or to make a prediction about a real product or system during the early stage of design. Suppose if you are facing any problem in your prototype, that means after spending of your all monies, then you are facing issues. Whatever the money we spend, everything is useless. So for reducing this cost, we can able to predict the failures in the design and simulation itself. So by that way, your modeling and simulations are very helpful. And modeling and simulations provide the designer with immediate feedback on your decision. That means by iterating or by virtual simulations, the designers will get a result at the same at the moment of a time they will get it out. So by your immediate feedback system, we can able to easily make a quick decision. So by this quick decision, we can able to save cost and time, and easily we can able to compete with our competitors. Then modeling and simulations promises a more comprehensive exploration of a design alternatives and a better performing final design. So by this process, we can able to use various options or various methodologies or various designs. We can able to try it for your optimization of the design. Modeling and simulations help the design to ensure process and product reliability and quality. It helps the design to ensure process and product reliability and quality. It ensures a high flexibility in product design and development process. It minimizes the risk of flawed design, thereby improving design efficiency. Now I am going to show you a small video about what is simulation and how it can be useful to improve your process.
What is simulation, and how can you use it to improve processes? Simulation is a uniquely powerful approach for making confident, evidence-based decisions that will improve your organization's efficiency and profitability. So, how does it work? Simulation is an effective technique for imitating an existing or proposed process. Software like Simulate enables you to build a visual representation of your process, similar to making a flowchart. Add rules for activities and resources, and the simulation will mimic real-life behavior. It's animated, so you can quickly see bottlenecks, overutilized resources, or any under-resourced elements. Make changes and see exactly how they'll affect the process in real life without any risk to your current performance. What can you simulate? You'll gain most benefit from simulating any process that's complex or costly to experiment with in real life. These might involve uncertainty, complex interactions, or elements of randomness, like varying customer or product arrival patterns. For example, reducing lines at a store checkout. You can simulate the possible behaviors. If the customer is served straight away, joins a line, or uses a self-checkout. By simulating arrival patterns over the week, you'll quickly see what will happen at peak times and where checkout lines are building up. Using the simulation, you can then quickly test ideas to reduce lines. You could add more employees, change work schedules, or add more checkout systems. You'll see exactly how each change will impact performance. Compare the results and costs to find the solution that reduces queues and delivers the best customer experience. When could simulation help you? If you face complex decisions, assess how changes will impact every aspect of your process in a risk-free environment. You're having problems with a process. Quickly highlight any inefficiencies in a process that could be impacting your bottom line. Your process doesn't exist yet. Plan new process and validate your ideas ahead of any investment. You need to understand the long-term impact of decisions. Test different scenarios and simulate weeks, months, or even years into the future within seconds. You need to build stakeholder buy-in. Easily communicate concepts through a visual and animated approach to process improvement. What challenges could you solve with simulation? Learn more about the benefits of simulation at simulate.com/solve.
Now I am going to show you a small video about the clinical pharmacological department, how they are effectively using the modeling and simulation tool in drug development. Now I am going to show you a small video about Lincoln Learning Solutions modeling and simulation in engineering, how they are effectively using, and what are the different types of simulations are available and they are using in engineering field.
Roche Clinical Pharmacology explains modeling and simulation. Joe and his project team are often challenged when it comes to determining the best design for a clinical trial. There are many questions that need to be answered, but not all scenarios can be tested. Annie, the clinical pharmacology representative, tells Joe that modeling and simulation approaches can help the team design the best studies. It's used in many different areas to help with decision-making, including weather forecasting, finance, and the aviation industry. Aviation engineers are asked to design new aeroplanes that will go faster at a lower cost. But not all aeroplane designs can be built and tested, so they develop computer models to predict how aeroplanes fly and then run simulations of the different designs. In the end, the aeroplane with the best results during the simulations is built. Annie describes how a similar approach can be used in drug development to help project teams make more informed decisions. By using computer models, Joe can predict the outcomes of different clinical trial design options. Joe decides to try this approach with his new drug. He wants to know how long the clinical trial should last to conclude the drug efficacy is superior to the standard of care. Similar to the aeroplanes, existing data and knowledge are integrated into a computer model. Models use mathematical equations to describe and link the different pieces of information. It usually takes weeks or months to develop a model, depending on its complexity. As new pieces of information become available, models are updated. Once a model is found to properly predict known system behaviors, such as reproducing observed efficacy to current treatments, it's then used for simulation. In simulation, what-if questions are addressed, like what would the expected efficacy be if the study was shortened by 3 months, and what would the effect of the drug be if a different dose were used. By simulating different scenarios that cannot be tested in a clinic, clinical pharmacology contributes by saving time and costs while ensuring the robustness of the study design. Joe has seen firsthand how modeling and simulation can help project teams design informative studies. He now knows how long his clinical trial should last, what the expected efficacy is, and what the effect of a different dose will be. He and Annie know that modeling and simulation can also address challenges beyond clinical trial design options, such as a target identification, disease understanding, competitor comparison, and the probability of success in late stages.
Now I am going to show you a small video about Lincoln Learning Solutions modeling and simulation in engineering, how they are effectively using, and what are the different types of simulations are available and they are using in engineering field.
Imagine living in a world that doesn't yet exist. In this world, you are the creator, and the only limit to creation is your imagination. Similarly, in engineering, models and simulations are made through the engineer's imagination and design that is created. They create models and simulations to bring their design to life before they are produced. There are three types of models, which include physical, mathematical, and process models. A physical model is a model that is made to have the same look and feel as the actual product. A mathematical model is one that uses numbers and relationships to describe parts of a product. Lastly, a process model is one that describes steps that need to be performed to accomplish a specific task. Similar to models, simulations are grouped into three main categories, which are live, virtual, and constructive simulations. A live simulation is one that uses real people utilizing real systems to model a design. An example of a live simulation would be firefighters or military personnel training for their jobs. They would be using real equipment to simulate live situations. A virtual simulation is one in which real people use and operate simulated systems to perform real tasks. Pilots use flight simulators for their career training, in which they can experience what it might be like to fly a real plane. Lastly, constructive simulations are ones that utilize simulated people and simulated situations. These simulations are created by real people and can show us what may happen in live and real situations. For example, if an engineer wanted to test the safety of equipment, they may choose to use constructive simulations. This would allow testing to take place on the equipment and fixes to be made before the equipment is produced. It would also keep people safe. Simulation is being used or has been used almost anywhere you look. It allows product designs and real-life situations to be tested and improved, keeps costs down on product design and implementation, and keeps people safe. From the designs of airplanes, video games, and cars, modeling and design is used in a wide variety of fields. No matter what's your interest, there is a place in the designed world for you.